What if your AI agent could instantly understand and use any software tool without you manually setting it up? That is the potential of MCP, which is a standardized way for AI agents to discover and use tools and data sources. The best way to explain MCP is to actually show you an example. And there is now an N8N community module that was published 2 days ago that you can actually play around with. So here I have a typical AI agent in N8N. This is a Google Calendar agent. And as you can see here, you have various tools, view calendar events, checking availability, updating and deleting events. And as you can see, for this calendar agent, I need to be quite specific around its capabilities. I need to create tools for different actions. And then within the system prompt for this calendar agent, I need to hard code some sort of procedure around how to actually use these tools. Now, agents can figure out how to use tools, but generally from my experience, you need to be quite descriptive with agents on how to actually use the tools to get the right outcome. So this is quite a time-consuming process, and it doesn't scale well with the more tools and the more agents that you have in a potential multi-agent system. However, with MCP, it's a completely different approach. So if we zoom in here, you can see that instead of listing the specific tools and the various actions, we now just have a single endpoint, which is list the tools. So you're going to an MCP server, let's say for Google Calendar, and the agent is asking, give me all of the available tools that you have. It'll respond with all of its tools, and then you can execute one of those tools. But it doesn't stop there. You can also ask it to provide prompt templates to use those tools. And I think there's huge potential in this aspect of it, because it's not enough to actually know what tools to call. That's the same as having any API endpoint. But to actually have prompt templates on how to call those tools to get the best outcome is very different from a standard API kind of documentation. The other thing you can do is you can ask the service to list the resources it has available. So this could be the contents of files, it could be database records, screenshots, images, live system data, and then you also have an action to get that specific resource to then bring it into the agent's context. So to compare the two approaches then, with the traditional N8N agent tool approach, you're being hyper-specific around what tools to call, and then in a system prompt, how to interact with those tools. Whereas in this approach, it's completely abstracted. And the beauty of this type of approach is that as more tools are added to, let's say, Google Calendar's MCP server, they'll automatically become available to your agent without you needing to actually edit the N8N workflow or the N8N agent itself. So these agents can actually evolve in their capabilities as tools get added on the server side, or maybe as tools improve on the server side. So as you can tell, there's huge potential for this type of architecture for AI agents of the future. And this N8N module that you see here was only released 2 days ago. So this is very raw. It's not a core module, it's a community module. So it will evolve and mature over time as the MCP standard evolves and matures as well. So in this video, I'm going to go through how to set up these MCP clients and servers to interact with the Brave search engine, Firecrawl scraping service, as well as the GitHub service. I also play around with setting up a Puppeteer agent, as well as trying to connect to Appify's MCP server. But before we do that, let's dive into what MCP actually is, how it compares to N8N's built-in agent tools, and whether it really will be the key to create smarter, more autonomous agents. I've published this MCP N8N workflow in the free resources section of our community, the AI Automators. Check out the link below to get access so that you can play around with MCP agents yourself. MCP stands for Model Context Protocol, and it's an open standard Anthropic published late last year. From my reading of this, the primary motivation by Anthropic on developing this type of open standard was more from a local or a desktop perspective. Anthropic has a product called Claude for Desktop, and there was clearly a mechanism needed to empower this application to interact with either local or remote services. And that's essentially what MCP is. It's a standardized way for AI models like Claude in a desktop environment here to interact with tools and data sources. Outside of Claude for Desktop, the majority of talk about MCP is in relation to AI code editors like Cursor and Windsurf. But MCP can be very useful for ChatGPT clones like LibreChat, where you can hook in different models locally and trigger internal or external services via MCP. If you're interested in getting MCP set up in Claude Desktop or in Cursor for AI coding, then check out this great video by my friend Rob, who goes through it brilliantly step by step. I'll leave a link for this in the description below. Anthropic have described MCP as a USB for AI models, and you can kind of see this here in this architectural diagram. You have your AI agent host, which could be Claude Desktop, or as we're going to go through in today's video, it could be N8N. And by hosting what they call an MCP client, that can then be plugged into any MCP server And that server then is connected into local or remote services to access files or APIs or databases or whatever it is. So having this concept of a USB connector is incredibly powerful because it can have lots of different servers and they're all then connected into your host. And because they're abstracted away from your application, they can be maintained themselves, new features can be added, they can be improved, and the agent will always get the benefits of the improved code. So this type of abstraction clearly has its benefits, but it also comes at a cost. If we look at a typical N8N AI agent tool, it's usually the application code that's triggering the API of the service directly and getting responses back. So clearly that's a lot simpler, there are a lot less moving parts. Whereas with having this middleman of an MCP server, you're absolutely adding to the complexity. And then there are also security concerns because traditionally your application, N8N for example, when connecting to a service will just be authenticating directly. So you just need to make sure that you secure your host and that the communication back and forth is encrypted. By adding in this additional layer, these MCP servers, the authentication happens at the server level here, no longer at the host. So this brings with it challenges for authentication, but also authorization. So are you authorized to carry out specific actions within the service, even if you are authenticated? While there is huge potential in MCP for agents, it is very much dependent on this standard actually being adopted by the industry. And there are so many examples in the past where great standards have been published, but shunned by key players for various commercial reasons. But whether it's MCP or a future standard that's published and adopted by everyone, there is clearly a need for some sort of seamless way to plug in software applications into our AI agents without needing to reinvent the wheel every time. So before jumping into the N8N module and implementation, let's have a quick look at the MCP architecture and some of the core features so we know what we're talking about. We have our host, which in this case is an AI agent hosted on N8N. And within that host application, you have what's called an MCP client. This MCP client is essentially what you see here. So these are effectively the tools of the agent. And that's connected to an MCP server, which needs to run somewhere, either permanently or ad hoc. And it usually has a public repository on GitHub that is available through different package managers, be it for Python or for Node. So for my scraping agent, which uses Firecrawl, this MCP server is available in this GitHub repository. And this is essentially the bridge then into the firecrawl.dev service. And within Firecrawl service, there is an API that the server is hitting. It can then scrape the web, it can carry out whatever actions it needs to do, and then it communicates back through the server, back to the client, and then the agent outputs. So we can see this here. If we connect up our chat interface, I'll clear my session and then I'll just say scrape this page and I'll just give it the web address of our website. And you can see it's going to the list tools to find out what this Firecrawl MCP server can do. It learns what its capabilities are, and then it goes to execute that tool in Firecrawl to scrape this page, and then it's going to respond with the scraped results. And as you can see, it's provided the scraped markdown of the page along with even the logo that's in the footer. So that was the full end-to-end from a request in the host through the client, through an MCP server to Firecrawl, and then back again, and it outputs the result. A key thing to talk about though is this MCP server and where it's hosted, because when I first heard server, I assumed it's like a web server. It's something that needs to be running at all times, listening for connections and relaying on. But actually that's not how I have this set up. So if we look here, I'm currently running this application on Elestio. So it's not running on my desktop, it's a remote server. I am still self-hosting it, but I didn't actually install this MCP server. So your options are you can either install it so that it's running permanently and listening for connections permanently, or you can use NPX, which essentially sets up a temporary server. It downloads the latest version of the package, and then it spins it up as a process on the machine. So if we jump back into here, these are the MCP clients, and this is the client configuration. But if you click into the credential, this is actually the command to spin up the server. So you can see here npx, we're triggering the Firecrawl MCP repo, we're passing in an environmental variable, which is my Firecrawl API key. So by actually triggering the client, it is spinning up the server to interact with Firecrawl service. And a lot of what you might have seen with MCP in other kind of YouTube videos is all code-based. That's why this is actually a no-code tutorial, because you can configure your clients and you can configure your servers all through this interface that you get from this community module, which is really cool. And the other services that I have hooked up then, Firecrawl is one, Brave Search is another. It's exactly the same thing. It's an npx command to execute the package. It downloads the latest package, spins it up as a process, and then it uses it to relay into the service. What's worth calling out as well is there are two ways of communicating with an MCP server. So there's a standard input-output, which is this stdio, or there's SSE, which is server-sent events. So here I'm using the standard input-output mechanism because npx, that's going to run locally on the server. Whereas if your MCP server is actually on a different machine somewhere else, you can only use SSE, these server-sent events, to actually communicate with it. And because desktop and local applications are one of the main use cases for MCP, it's quite common for this entire architecture to be local to your machine. So you could be running a host, it could be N8N locally, Cursor, Windsurf, Claude Desktop, whatever it is. You can communicate with your MCP server. You still can use SSE, you would just set it as localhost. And from there, then it can interact with the service. And it doesn't need to be software. You could be interacting with the file system. You could be interacting with command line applications to trigger browser automation, for example. So there is a lot of power in running this locally and leveraging all of the resources on your local machine. It is a little bit more secure doing that, but you still need to be very careful with what MCP server you actually download because you are installing that on your machine. So we've covered a lot of these key concepts already. So you can see that example of tools and how you can list tools and execute tools via an MCP server. With the concept of prompts, the server can provide prompt templates to the client. That way it can provide a standardized way of communicating with the tools, which should result in much more reliable outcomes from both the server and the agent. With resources, the MCP server can expose data and content from your service. That could be file contents, database records, images, screenshots, whatever it is. Those are the three main concepts involved. With transports, you saw how you can interact using standard input output, which is more local based, or SSE, server sent events, which is for more remote communication with an MCP server. Sampling is a really interesting concept because it's all about human in the loop, and it allows an MCP server to communicate with the client, and therefore an AI agent who can relay to a user to get it to confirm or reject a specific prompt or a specific action. So this opens up a huge amount of flexibility and functionality around this human-in-the-loop design pattern. And then with routes, it essentially informs the server as to the boundaries of the service. So it could be different projects, for example. It could be project folders, repository locations, maybe specific kind of client endpoints, something like that. If we're to compare MCP to N8N's agent tools, I think they very much complement each other. There is a large overlap in the sense that with agent tools, you can trigger actions within a service, and with MCP, you can do the exact same thing. So there's clearly overlap there, but obviously the approaches are different. With MCP's decoupled nature, as you can see there, it's very much suited to general purpose agents that could carry out any number of actions within a service. With more traditional N8N agent tools, you have much more control over the agent. You can pick and choose the exact tools that you want to integrate with. You can make sure that they have the correct permissions to actually carry out these actions. So in this case, for example, the calendar agent, if you didn't want to give it the ability to delete an event, you simply just remove the tool. At this point now, that agent cannot delete the event. So you have so much more control, and then you can get quite specific in your system prompt around how the agent should trigger these tools. Whereas with the MCP approach, it's so abstracted that it's much more general purpose. Any of the tools that are listed, they could potentially execute unless you lock them down at the MCP server level. And then if new tools are added to the MCP server, they'll immediately become available to the agent. So that brings about questions as to, backwards compatibility of tools, as well as the repeatability of the actions by the agent. You could test an MCP agent the way I've done here by asking it to scrape a particular website, and it might produce a consistent result as it is doing here. Whereas tomorrow, maybe Firecrawl will add another 10 tools to the MCP server, and suddenly the agent no longer picks the one that produced this reliable output, it picks a different one and it comes up with a different output. So they are very different use cases, I think, and I think that's why they do complement each other. A few weeks ago, I created HAL 9001, which is this mega multi-agent N8N system, which acts as your personal assistant. And as you can see, it automates or connects with everything across 26 different sub-agents. And it was a really fun project, but to actually get this working reliably would require going through all 26 agents, testing every tool, prompting each specific agent to make sure that it's doing the right things to get the right outcome from each tool. So for such a broad multi-agent team, it's just unscalable in a sense to actually be production ready. Whereas you could have MCP servers for each of the 26 services, and it provides a full broad menu of all the tools. And then if the prompt templates were used properly for these services, it would educate the agent at runtime on how best to interact with those tools to get the right outcome. And I think that's where the real potential is in MCP, is for these really broad agents like HAL 9001. We give this one away for free, so I'll leave a link in the description so you can watch the video and access this template. And as well, the MCP blueprints that I'm going through today, you'll be able to download these blueprints and play around with them yourselves. So let's dive in and I'll show you step by step on how to actually set these up. So first things first, you need to go to this N8N nodes MCP page. This has full step-by-step instructions on how to actually configure this community module. And the other thing to mention is that it's a community module. It's not part of core yet. It may be in the future, particularly if MCP actually takes off as a standard and is adopted by the industry. But on this page, it has a link to the installation guide on how you can actually install and manage these community nodes. Essentially, what you're doing is you're copying out the package name, and then within your N8N instance, you go to Settings, Community Nodes. You can see I have it set up here, and you click Install, and you just paste in your package name. Now, because it's a community node, it is unverified code from N8N's perspective, so you need to agree to the disclaimer, and then you click Install. And then that sets up this node within your application, and then you can start using it. This isn't available in N8N Cloud, just to be clear. So you will have to be self-hosting this either locally or as I'm doing on a remote server like with Alestio. But anything like Render, Railway, or any of the cloud platforms will work here. So once you have your community module installed, if you click Create Workflow, for example, and we'll just trigger this manually for the moment, if you click on the plus and just type in MCP, you'll see that there's an MCP client, and you can choose List Available Tools, for example. I'll set up a new connection here to hit Firecrawl's API. So these are the two transport options that I discussed, standard input-output and the server-sent events. So we'll choose standard input-output, and then let's go to Firecrawl's MCP documentation, which you can see here. And if you scroll down here, you can see the commands and the arguments you need to pass. So it's npx, which is there. So it's -y, which basically means it'll confirm any prompts that it's asked while it's installing. And then Firecrawl MCP, so copy that out. And then the Firecrawl API key, so you need to grab that. I'll just set this to expression. So Firecrawl API key equals, and then you need to go and get your API key. Okay, so I have that there. And you just paste that in. I'll cycle this key after this video, and then you just click save. So that's the server essentially set up. You haven't actually installed this package, but because it's npx, it's going to temporarily install on runtime. So then within the client, you can choose one of the operations. So we'll just list tools for a second. So we save that and click test workflow. Okay, and that was successful. And if we double click, you can then see all of the tools that are available within this MCP server. So we have Firecrawl scrape, that's a description, and then it talks to the schema that needs to be passed. Now, I don't think it provides enough details here, and maybe the standard will evolve over time, but I think it needs to provide a lot more information for the AI agent to make the right call as to how to populate these parameters. There's Firecrawl map, which is a way of mapping URLs within Firecrawl, searching, which is a new feature, I think, and a deep research feature, which is definitely very new. But they are the tools then that are available. And then you can execute one of those tools. So if you go to MCP client, execute a tool. Now you'll need to provide it a tool name. Now it doesn't make too much sense to actually put this in dynamically because this may change, new tools may be added. But for the moment, I'll just put in, let's say, Firecrawl scrape. I'll just hard code it. And then tool parameters, you would then need to hard code. And that's why it makes sense for an AI agent to do this. Because if you're going to this trouble, you may as well just set up the actual standard agent tool. So you want the AI agent to do this, but you can execute it standalone like that. But then to get the AI agent to do it, let's just add a node, AI agent. And then if we delete all of that out, we'll use a chat trigger, connect it all up. So the chat trigger is going into there. We use a chat model. I usually use GPT-4o as standard. And then we'll just give it some memory just so that it can keep track of itself. And then in terms of the tool, you can then use the MCP client tool, which is essentially the same thing, except it can be triggered by an AI agent. Okay, so if I just say what tools are available, it goes and it spins up that Firecrawl MCP server, uses it to relay information to Firecrawl service, responds back to this little client here, which then responds back to the host, which is the AI agent. And then here is the answer. So it can scrape, it can map, it can crawl, it can batch scrape, it can carry out deep research. And when you're getting this up and running, if you run into issues actually getting the agent to trigger this tool, you need to set up this environmental variable, which is to allow community packages be used as AI agent tools. So within Alestio actually runs Docker images of N8N. So I needed to add this to my Docker Compose. So that's just something to be aware of, but that'll differ depending on what environment you're working on. Okay, so it can now list tools. So then let's add another one, which is MCP execute a tool. And then for tool name, what we're going to do here is we want the AI to dynamically input this, as well as the tool parameters. Now, in the latest version of N8N, there's this great little button that you can click so that the AI automatically populates that out. So we'll just do that there. That's not here for some reason, but we can just put in an expression, and then it's $ from AI. Let's call this tool name, and then we'll just say populate this with the tool name from the list tool results, something like that. Now let's try this. So can you scrape my website, theaiautomators.com, and let's see what it does. So it goes to the list tools. Now, it should have been in memory, but no harm getting an updated version. Maybe something has changed. Now, we have got an error, so let's have a look. Failed to connect to MCP server. Oh yeah, I selected the wrong credential. So there we go. Okay, it's working again. Now, within Firecrawl, actually, if we go into the activity logs, we'll probably see this crawl running. Yeah, there it is, 1403. It has scraped, took about 10 seconds and was successful. When we come back in here then, so it's all green, and it looks like it's outputted all of the HTML from the page. Yeah, and it's taken a bit of time, and it's just thrown an error. And yeah, interesting. So the maximum context length of 128,000 tokens was breached, 376,000 tokens. And that's a really good example of a potential failing. I don't even know, is this a failing in MCP or a failing in the current state of AI agents? It isn't able to understand that there's too many tokens being passed to the LLM and actually take kind of a different approach. Can you provide the markdown only, please? I'm gonna try it that way. And Firecrawl usually does it either in markdown or HTML or both. So markdown shouldn't be that many tokens. So that returned and said I couldn't do it. And I believe what's happened is it hasn't actually structured the parameters correctly. I think this output format needs to be an array and it's just a value. Let's get it to do it again and see has it learned from its mistake. And this is what I mean about how there's not enough information coming back from this list tools call. It needs to essentially provide full API documentation. You're seeing formats here, but it's not telling you it needs to be an array. So it very likely could get it wrong here again. It's taken a bit longer. It might have actually got it right. Yeah, so that worked. And you can see the full markdown there. So it does work. Clearly not ready for the prime time just yet. I think the reliability is an issue. I think this one specifically might be just a lack of a description by Firecrawl on the actual tool. If they dumped all of their documentation for this endpoint to explain these parameters into the description, the AI agent would have a much better understanding of how to actually interact with it. The other thing then is this Firecrawl MCP server, it can only list tools and execute. So if we try, let's say, list prompts, because I really believe the listing of prompts is going to be one of the biggest benefits of MCP. So if you ask it then, can you list prompts? It's going to hit this, but it's going to throw an error, I think. Yeah, and the reason being is that this MCP server doesn't actually offer prompts. So this probably needs maybe a more graceful error handling within maybe the N8N community module. So if we look at some of the other MCP servers I've connected to, if we come over here, this is the Brave search engine. So you can see there's Brave search, NPX, this is the package name. And then if we just ask it a question, let's say, what's the weather like in Galway? It gets a list of the tools that it can trigger on the Brave search engine. There's Brave Web Search, Brave Local Search, and then it executes that tool, which it's done there, and it's got a link to the weather. That's semi-worked. Let's see what it actually can do. Are there any Japanese restaurants in Dublin? I've never used Brave Search before, so I have no idea is it any good or not. Okay, do we have an answer? And we don't. And we've hit some sort of API limit, too many requests. I am on the free plan on Brave, so that's probably why that happened. So clearly the vision of MCP and the idea that you can plug any piece of software into it and your agents will simply work is far from reality at the moment. Yeah, still hitting an issue on that one. I'm absolutely leaving this in the video though, because like MCP has such potential. We're very far from this being kind of production ready for N8N at the moment, I think. If we look at the GitHub agent one that I have set up, this one actually does provide a list of resources. So actually, let's try that one. List your resources. Let's see what it can do. Oh, it's going to give us both. Cool. Okay, here's our answer. Yeah, so there's the browser console logs is what's listed under resources. And then for tools, there's 17 different tools. And this makes sense because MCP is used a huge amount for AI coding, and then obviously pushing to repos on GitHub is a core feature of AI coding that would be needed. So this is definitely a very mature server that you can kind of see there. So yeah, there's 3 different MCP servers with kind of mixed outcomes in terms of testing. So then 2 others worth discussing. Number 1 is the Puppeteer agent, because with MCP, you can actually trigger Puppeteer for browser automation, similar to OpenAI's operator or browser use. The issue I have with this is that this is running on a remote server, and it's actually running inside a Docker container on a remote server. So if I actually try to execute Puppeteer, for example, let's even try it here, and then I'll just say, go to my website, theaiautomators.com. So this is going to throw an error because it doesn't have permissions within a Docker container to actually trigger a browser automation. So you can see there, failed to execute operation, it's not permitted. If you try this on your local machine, that possibly will work, whereas it obviously won't work there because we're remote in Docker. The other one I tried then was this Appify agent. So Appify has a remote MCP server. And I really wanted to test this out because of these 2 transport mechanisms. It has an MCP server actor where you can send it SSE events, which is this one. And I'll provide a link to this in our resources as well. So I spent like an hour and a half trying to get this working. And I got some of the way. I was able to actually spin up the MCP server for my account. And I was able to trigger the MCP server within Appify's console. I wasn't actually able to get it working here though. So if I look into the tools, if I go into the Appify connection, I have my SSE URL set and the post endpoint set to receive messages. However, it wasn't able to actually communicate through this. So I'm not sure, is this because Appify have a non-standard implementation of MCP, or is it that this MCP community module just can't handle this type of use case? So if anyone does get it working, let me know in the comments below. So then on to a verdict. Is MCP going to change the nature of AI agents in general and specifically in N8N? Well, definitely not in the short term. As you can see from this testing and this setup, it encounters more issues, I think, than standard agent tools. But definitely the potential is there. This community module is only a few days old. MCP is a relatively new standard. I'd love to know what you think in the comments below. Do you see a future for MCP in the likes of N8N for this level of kind of abstraction around services and tools? And don't forget, you can access this blueprint as well as our HAL 9001 personal assistant in our community, the AI Automators. We have a free resources section where you can access both of these, and click the link in the description below for more. Thanks for watching, and I'll see you in the next one.